we have a couple of questions related to tsunami evacuation. So Shane would like to know about inundation depths for Napier. So his question is, what is the anticipated inundation depth for the Napier area? So heading back to the Paraiti Hills, in a near source tsunami scenario, and how quickly might that depth be reached? So just wondering if the roof of a house would be an option, if there was time, if time was seriously limited, or there was severe land damage that would make getting to higher ground impossible. And then we have a similar question from Graham as well, who was also asking about that sort of vertical evacuation structure situation. So what is your opinion regarding the role of vertical evacuation structures in saving lives from tsunami? Do you believe that such structures are worthwhile and should be partially funded by the government? So I think we'll first go over to William. What do we need to know about potential inundation depth for the Napier area? And then maybe yourself and Liam as well. What are your thoughts on the use of vertical evacuation structures here in New Zealand?
Okay, well, thanks for the question. In terms of inundation depths for the Napier area, there really isn't one single answer because it really depends a lot on the scenario. I mean, the particulars of the earthquake and the specifics of the location. So if you Google Hikurangi response plan, you'll see a report that we did some time ago where we modeled a few different magnitude 8.9 Hikurangi subduction zone earthquakes and looked at their inundations in Napier. And even for the same fault and the same magnitude, the specific details of the earthquake made quite a few differences to how far the inundation extended and what the depths were. In terms of how the inundation is distributed spatially, to look at a few of those typical scenarios of large Hikurangi earthquakes from that report, you might have a flow depth of perhaps 4 meters down by the port or Ahuriri on low-lying land. And then the flow depth tapers off as you sort of head back, some of those scenarios reaching the foothills. But, you know, they're obviously getting, well, they're getting thinner and thinner in depth in generally as you head it further inland. In terms of the timing, in our models for Hikurangi subduction earthquakes, we're typically finding somewhere between 30 and 50 minutes to reach the peak of the first really significant waves. That's time to reach the coast, and so there'll be a little bit of extra time for it to travel further inland. Although I would comment that sometimes there's some smaller waves that arrive earlier. So if you're really down by the coast, you want to get out as quickly as possible. There are also some other faults in Hawke's Bay that are a little bit closer to the coast than where the Hikurangi plate boundary comes to the surface. So those could also arrive a little bit earlier, but they also wouldn't unlikely to be as big a tsunami as from the Hikurangi subduction zone. In terms of evacuating to the roof of a house, for me personally, that would be very much the absolute last resort. So by far better, if at all possible, to get to high ground or go inland and get out of the tsunami evacuation zone. I wouldn't try to do that kind of evacuating to the roof of my house unless it was absolutely clear I had no alternatives. For instance, I could see the tsunami coming, and I had no time to do anything else. The reasons for that: remember that this is following a really big earthquake, so your house might not be as structurally sound as it normally is, for one thing. Another, if your house gets hit by the tsunami, even if you're above the water level, your house may move off its foundations or take damage. There may also be debris in the tsunami, so you might be above the water level, but if there is a boat or a container or some logs, they may reach you even if you're above the water level. So that kind of thing, very much last resort. I think it's fair to say that there are some areas of the country where it is very difficult for people to evacuate on foot in the time that's required. It's very challenging. So some parts of southern Napier, also some areas of Petone, and investigating the possibility of vertical evacuation structures, which are purpose-built buildings or structures or designated tall, strong buildings for people to evacuate in, is definitely something to be considered in those places, in my opinion, where it's particularly challenging for people to evacuate otherwise. Those buildings would be tested against many different models to make sure that they were high enough with a good margin of safety and that they had good earthquake strength and would cope with the number of people going there. I'll also hand that question over to Liam to comment on that.
Thanks for that, William. I think William's done a pretty good job at covering most of the key aspects. I think the key things is an understanding of the loading, and particularly where we've got these events that we don't have much time to evacuate. Those are usually the ones that you're going to have quite significant shaking at the same time. So one of those key question marks is, how can we understand how our building will perform initially for an earthquake, and then following that from the sort of quite different characteristics that are loading that would come from a tsunami. And there's a fair few unknowns around that, and a lot of active research trying to understand for New Zealand building design, how do our sorts of designs perform when we see that sort of concurrent loading occurring. So I'd agree with William, if we can find a solution to be able to achieve that, then that's the way we want to go, but we need to first delve a bit more into those sorts of aspects, as well as aspects of how long will people have to be there, what are the foundation soils like. Caroline mentioned liquefaction, so unfortunately we've also, in a lot of these areas, we've got that as an issue too. So if you've got quite difficult soils to deal with in terms of designing quite a big, probably heavy structure, those sort of work against each other a little bit when we're thinking about liquefaction and earthquake and tsunami. So plenty of active work in that space to try to find a solution.